Hi everyone, in this video we will be talking about two topics for 3D chapter for mathematics and IIT JEE preparation. The topics are that basically we will be dealing by doing problems on finding perpendicular distance of a point from a line, and we will be finding the equation of line perpendicular to two lines given. So these are small topics, however, as like in many of the math topics, basically this is sort of an approach that you should learn of how to solve problems like these. So let us start by finding the perpendicular distance of a point from a line. So the first topic we will be doing is that we have a line, we have been given, let us say a point A, and that is A vector, we have been given B vector which is a parallel vector, and we have been given a point P, let us call it P vector, and we have been asked to find the perpendicular distance of the point from a line. So you may recall this type of problems in 2D in straight lines basically, but it is not 3D, we have 3-dimensional geometry. So how will we solve this problem? So one of the approaches to start this is to think that there is a point C here, let us call it C vector, and the idea is that we know C vector would be A vector plus some lambda B vector, because that is the line, this point is on the line, and PC vector is perpendicular to B vector. This is what we know, right? So we know that these are the two conditions we know, that PC vector is perpendicular to the parallel vector, because this is the perpendicular on the line, so it has to be perpendicular to the parallel vector. So it should flash to you that the condition of perpendicularity is PC vector dot B is 0. Again, the knowledge of vectors is super critical in this chapter. I have emphasized that many times in the last two videos also. PC vector is nothing but C vector minus P vector dotted with B vector is equal to 0, and C vector is nothing but A plus lambda B vector minus P vector dotted with B is equal to 0, right. So if you were to find the value of lambda here, you can get the value of lambda as P minus A dotted with B divided by mod B square. So now you got the value of lambda, so you can calculate the point and then you can calculate the distance, right. So I mean, this is just an sort of I hope you are able to understand and follow what we are doing here. So you can solve this equation basically using the associative property. You can open the brackets and then rearrange to get this. Let us just do a problem on this so that you can quickly understand. We have been given P is basically 1, 2, 3, and the line is x minus 6 by 3 is equal to y minus 7 by 2 is equal to z minus 7 by minus 2. Okay. So now how will we find lambda? So we know the formula of lambda. I would just suggest you to remember this, but you may want to quickly derive it in the paper also. It's up to you, but I would recommend you to just remember it. It's very easy to remember. It's P vector minus A vector dot B vector. So P minus A vector dot B vector and divided by mod B square. So here P vector is I cap plus j cap 2j cap plus 3k cap. A vector is 6I cap. So A vector is the one which is in the numerator. Always remember the coordinate form and how to convert it into the vector form. 7j cap plus 7k cap. And B vector is 3I cap plus 2j cap minus 2k cap, right. So if I were to do lambda here, this would become P vector minus A vector, which is minus 5I minus 5j minus 4k dotted with 3I plus 2j minus 2k, P vector minus A vector dotted with B vector divided by mod B square, and mod B square is 3 square plus 2 square plus 2 square, which is 8 plus 9, which is 17. And if you will do this, this will become minus 15 plus 10 minus 10 plus 8, which is nothing but minus 17. So, lambda is equal to minus 1. Okay. So, the point is actually the point C is A vector minus B vector, and the point, if you will calculate that point, it comes out to be 3 I cap plus 5 j cap plus 9 k cap, and the distance PC mod would be 2 square plus 3 square and that comes out to be 7. Okay, so you can find the value of PC mod, right? You know the point C now, so you can find the distance by just taking the difference of x component square, then y component square, then z component square, and that comes out to be 7. And I hope that this is very obvious for you how to solve this type of problems, and if you are still not very comfortable, please practice. Just make some problems yourself, make an equation of a line, find a point, and then do the problems. It's very easy. I think like if you do this many number of times, it should be quick for you to remember. Let me give you one more homework problem so that you can do it on your own. And the homework problem is, so homework is find a point on y axis such that perpendicular distance from the point to line x equal to y equal to z is unity. Okay, so this is the opposite question that you have been given. You have been asked to find a point on y axis such that the perpendicular distance from the point to the line is unity. So, how will you do this problem? So, you can assume a problem, you can assume the point as 0 k comma 0 comma k comma 0, and then proceed now completely the same way. You can very quickly find the value of this thing, and then you can calculate PC, and then you can equate that to 1 to find the value of k. So, please do this problem. I think this will give you a very nice practice to understand how to solve the problems of perpendicular distance from a point to the line. Okay. Now, let us do another problem, that is which I wanted to do. I will basically not be giving you any physical, through something through variables. I just want to directly do an example of that problem, because that example will be enough for you to understand. So, the question says that we have been given two lines, x minus 1 by 1 is equal to y minus 2 by 2 is equal to z minus 3 by 3. Right, and then you have been told that line 1 L1 is this, L2 has been given us to x minus 2 by 4 is equal to x minus 3 by 5 equal to x minus 1 by 6. Okay. The question says find the line perpendicular to L1 and L2 and passing through 1 1 1. This has been asked how to solve this problem. So, you have been given line L1. Let me say, let me write answer here. So, let us say this is L1, this is L2. You have been given B1 vector, A1 vector and B2 vector, and you have to find the line 3, for which you just know one thing, that it is perpendicular to both and it passes through the point. So, to find the equation of a line, you need a point which you already have, but you need a parallel vector. And what is the speciality of that parallel vector? That it is perpendicular to line L1 and the third line is perpendicular to both L1 and L2. Hence, the parallel vector will be perpendicular to both B1 and B2, and as soon as I say this, it should flash into your mind that this is basically asking you to take a cross product. That is it. I mean, if you cannot recall this, please become more thorough with understanding the physical meaning of dot product and cross product. We have discussed here dot product perpendicularity condition of dot product already. We have done in the last video that dot product is used for finding angles. So, as soon as I use, and just it should just stick to your mind that a vector perpendicular to the two vectors is the cross product of two vectors. So, what you have to do is you have to find B3 vector, which is B1 cross B2, and if you do, and you should remember that for taking cross product you have to do this ijk and then opening up the determinant. So, if you do that, this will be I minus 3 plus j into 6 plus k into minus 3. So, is this perpendicular to both 1, 2, 3? So, if you take dot product with 1, so you should remember the condition of perpendicularity is dot product is 0. So, if you take minus 3 plus 12 minus 9, basically dotted with B1 is 0. If you dot with B2, it is minus 12 plus 30 minus 18. So, get 30 minus 30 is 0. So, it is perpendicular to both B1 and B2, and you already have a point. So, the line equation of line L3 could be easily written as x minus 1 is equal to y minus 1 is equal to z minus 1. The point has come on the numerator, and by denominator minus 3, 6 and minus 3. So, this line is perpendicular to both the lines and passes through 1, 1, 1. So, I hope that you are able to understand this, understand how important the understanding of vectors is here, and how I solved the problems here. So, we discussed two things here. One, how to find the perpendicular distance of a point from a line, and for that we can remember this formula of lambda. We calculate lambda, calculate the point, and then when you calculate the point, you can get the coordinates of that point and then subtract with the original point to get the distance. I have given you a homework problem, so please do that at home. And then we did a problem of finding a line perpendicular to the two lines. For that, you need to take the cross product of the parallel vectors, and then you will get the equation of a line. Okay. So, I hope you enjoyed this video. There are a lot more interesting videos and topics in this chapter. So, I hope to see you in the next video. Thank you.